Okay, so this is the third segment in our BioChem Basics, and we're going to take a look at isomers right now. So we've already seen one of our what's called a constitutional or structural isomer. Oh, hang on. Let's do a definition. So an isomer is the same molecular formula, different molecular structure. So in a constitutional or structural isomer, this is a different picture than you have in your notes, but I am going to give you this in the additional resources section. If you look here, this fluorine, this is a halide we're looking at, is different. We saw this when I drew the isopropanol versus the propanol. So this would be an isofluoride versus a fluoride over here. Then we have what's called spatial isomers, and I'm going to switch colors because I'm writing in red and it's in red, so that's not going to work. And spatial isomers can be divided into all of these different categories, but the most important ones to us are these guys, cis-trans isomers, and these guys here called enantiomers. So cis-trans is kind of, it sounds more difficult than it really is. So whatever the functional group is, or the carbon segments that are hanging off, they're the same, or they're on the same side if they are cis. So this is a cis molecule here. And trans would mean they're transverse from each other. That's where it gets its name. And that's this molecule here, where you can see that they're transverse from each other. And cis and trans isomers sometimes will act very differently from each other based on who those other structures are around or can allow in. So they may be very different to each other. And the other ones that we want to talk about are these guys over here, and they're called enantiomers, and that's not a very good drawing. Hang on, let's erase that and start over again. Where'd our... There we are. So this is a mirror in between those two molecules, and basically that's what an enantiomer is. Enantiomers are mirror images of each other. Sometimes you'll hear them referred to as L and then D, and it's based on the digits of the hands being lateral or distal or that type of thing. But basically what you just need to know is that they're mirror images of each other. So, you can get into, molecules having, 5, 6, 7, 10 carbons, and then are they enantiomers, or are they cis-trans, or are they even just isomers of each other? One of the questions on the test for this unit asks about whether they are isomers or not. Basically, the thing you need to remember is this statement up here. You figure out if they're an isomer based on whether they have the same molecular formula or they are different molecular formulas. Is it all the same number of carbons? Do you have 10 carbons still? They're just rearranged differently. That's basically what you're looking for when we're talking about isomers. And again, the most important ones are your structural isomers over here and your spatial isomers over here. And that's basically what an isomer is.